Hello everyone, my name is Ricardo Kleinlein and I'm glad to be here to introduce you our approach when tackling this edition of the Predicting Media Memorability Challenge at MediaEval 2020.
We shall proceed as shown in this slide. Development dataset is composed by just 1000 samples, smaller than most other memorability datasets. It is interesting to notice the distribution of scores. Short-term scores are generally high, whereas long-term scores show a distribution with more variability, yet also very high, with many samples having a score of 1. Our approach tackles the challenge as an ensemble of single-modality learning models, whose predictions conform the input for a final support vector regressor. Whereas every learner has the same architecture, every one of them receives different input features. Our choice is motivated by the sequential nature of the data, as well as our desire to focus on specific regions of the input data. To work with text captions, we aggregate every word lemma from all available captions of a video and obtain their word-to-vec embeddings. This way, every video is represented by a sequence of 300-dimensional pre-trained embeddings, one per word. Likewise, the audio signal of every video is processed in order to obtain a sequential 128-dimensional representation, with every embedding spanning approximately 1 second of audio. These embeddings are computed applying a default configuration of the VGGS model pre-trained on AudioSet, a large-scale audio event detection dataset. We hypothesize that motion within videos are of particular relevance in video memorability. Therefore, we apply a lead flow net, a well-known optical flow estimation model, to the frames of every video extracted at 3 frames per second. We further process these optical flow feature maps through a principal component analysis, obtaining a 128-dimensional embedding for every frame extracted. On a 5-fold cross-validation scheme over development data, no single modality model achieves a high Spearman coefficient value. The ensemble of their predictions does improve the Spearman's value, but only of the development partition. When faced against the official test data, our system's performance drastically drops to almost zero values. We claim that larger datasets showing more variability in terms of the score distribution would benefit more from our deep learning-based approach. We reckon that our ensemble systems are learning is but the average memorability score. Further work on small datasets include an evaluation of more specific data encodings, so most of the information for the task be contained within the input data, leading to simpler learning environments. This is it, so thank you very much for your attention.